Welcome to Honors Geometry, Lesson 4.5 through 4.6, dealing with proofs that triangles are congruent. We will just get a little more deep and extensive about proving triangles congruent, other than just saying angle, side angle, or side angle, side, or whatever. So here we go. Are you ready? Let's go ahead and move right in on it. Alright, here we've got a two-column proof. Given that AB is perpendicular to CB and that BD is perpendicular to AC, I want you to prove that triangle ABD is congruent to triangle CBD. So first we'll start with a given. We'll start with AB congruent to segment CB, and that's given. And to help us see which method, whenever we make a statement over here about congruence, we're going to come over on the picture and mark it. So AB congruent to CB. 2. Segment BD is perpendicular to segment AC. 2. Given. Alright, how can we use that? I think we can say that angle ADB and angle CDB are right angles. Why can we say those are right angles? Come on, why? Well, you just said they were perpendicular. That's a definition of perpendicular segments. So now we'll go ahead and mark that on our picture. Alright, anytime we're trying to prove triangles are congruent, what are we going to look for? We're going to try to look for hypotenuse leg. So that's the first thing we're going to look. Is there any way to get AD congruent to CD, or is there any way to get BD congruent to BD? Yes, of course there is. We can, just by looking at the picture, get segment BD congruent to segment BD. Why can we get those segments congruent to each other? Well, of course, the reflexive property. So we'll go on up here and mark it congruent to itself. And then we've got the hypotenuse and leg of a right triangle congruent to the hypotenuse and leg of another right triangle. So now we can say triangle ABD is congruent to triangle, triangle CBD, hypotenuse leg theorem. Just like that, we've proved that our triangles are congruent. Let's try another one. Same picture, just about same everything, not quite. Well, we'll start with the first given. AB is congruent to CB, given. Remember to do what next? When you say a congruent statement, mark it. So we'll go like that, and we'll go like that. And now we're given that angle ABD is congruent to angle CBD. And you know what, if you really wanted to put those givens in one statement, you could probably do that too. Alright, we'll mark those angles congruent to each other. And once again, we can get BD congruent to itself. Why is anything congruent or equal to itself? That's right, the reflexive property. And now that we've marked this triangle up, I think you can see why the two triangles are congruent. I hope you can. As much time as you've spent on them now. Triangle ABD is congruent to triangle CBD. You've got two sides and an included angle. Two sides and the included angle. That's right. Side angle, side postulate. And that's why the two triangles are congruent. Alright, let's go ahead and move on. Oh, Mr. Manning, really? Yes. Oops. Alright, start out with given. We'll say that segment CX is congruent to segment CB because it's given. When you say it, mark it. CX congruent to BX. 2. Angle A congruent to angle Y. When you say it, mark it. So, alright, those are our only two givens. Is there anything else that you could possibly find? Whoops. And you should be looking at that picture and seeing a couple of vertical angles that are congruent to each other. You should be saying angle ACB is congruent to angle YCX. This angle is congruent to that angle. Why? Because of the vertical angle theorem, which says vertical angles are congruent. So, we now have enough parts to figure out why triangle ABD is congruent to triangle CBD. Okay, you've got two angles in the non-included side. Two angles in the non-included side in the corresponding order. Look, it's one arc, two arcs, and then the side. One arc, two arcs, and then the side. You betcha. Angle, angle, side theorem. And that gets the triangles congruent, and that's what we were trying to prove. I love how the last statement in your proof is always going to be what you're trying to prove. That's just so cool. Alright, one more proof, and then I'll let you get working on your homework as soon as you come into class. Well, maybe let you get working on your homework. You might have to do a do now or something. Alright, here we go. This time, we're not trying to prove the triangles are congruent. We're trying to prove that CA is congruent to CY. A part of a triangle is congruent to another part of another triangle. So, the idea here is we're going to first say that the triangles are congruent. Then we'll say the parts are congruent using the definition of congruent triangles. Or we can also say it this way. Corresponding parts of congruent triangles are congruent. So anyway, that's what we're going to try to do. So we're going to try to get these two triangles congruent. State number 1. CX is congruent to BX. Those two segments are congruent. Given. Where is that? Oh yeah. CX congruent to BX. 2. Angle X is congruent to angle B. 2. Given. Angle B with two arcs congruent to angle X with two arcs. Well, doggone it, you should be seeing these vertical angles are congruent again. So 3. Angle ACB is congruent to angle YCX because of the vertical angle theorem. So that angle congruent to that angle. Now looking at the two pictures, you've got two angles in the included side, two angles in the included side. That's right. Triangle ACB is congruent to triangle YCX using the angle side angle. Careful how you spell that. Postulate. There you go. And now we can say that CA is congruent to CY Why? Because we've showed that the triangles are congruent, so corresponding parts of congruent triangles are congruent. CPCTC. 3 C's with a P and a T in the middle. Well, that's what I always like to say. Anyway, that is how you're going to prove in a 2-column proof that parts of triangles are congruent to parts. Get the triangles congruent, then say the parts are congruent using corresponding parts. Congruent triangles are congruent. This will conclude lesson 4.5, 4.6 on proofs. Enjoy!